Avery.
Ryan.
Mufasa. Oh, I didn't notice you there. Here, come a little closer. Hey guys. Welcome to ARMS.
ARMS. Physics.
Welcome to ARMS. Science. Today we'll be talking about
Physics. More specifically, thermodynamics.
But sir, what is thermodynamics?
What is thermodynamics, you asked? Thermodynamics. Thermodynamics is a branch of physics that deals with the study of energy and its transformation in different forms.
You know that microwave you use to heat up them late night snacks?
Oh my goodness. Oh, it's so good.
Or that fire you dance around while camping?
No, God! No, God, please, no! No!
All those can hear to the laws of thermodynamics.
there are 3 laws in thermodynamics. The first law, which states that energy cannot be created nor destroyed. So if you're trying to lose that weight,
What is wrong with you? No, seriously.
whoa, what you been eating, bro? Them too many McDoubles.
Oh my God.
Sorry to break it to you, but it's not just gonna disappear. You can't just will the calories away. It doesn't work like that.
But seriously, the first law of thermodynamics states that energy cannot be created nor destroyed, but it can be converted from one form to another. This principle is also known as the law of conservation of energy. It applies that the total energy of a closed system remains constant, and any changes in the system's internal energy is due to the transfer of energy in throughout the system.
Now on to the second law of thermodynamics, which is where things get interesting. Basically says that everything in the universe is slowly but surely moving towards chaos and disorder, kind of like my bedroom on a Monday morning. So if you've ever wondered why it's so hard to keep your room tidy, blame the second law, or blame yourself. Or blame yourself.
So the second law of thermodynamics states that the total entropy of a closed system always increases over time, and the entropy is the measure of disorder and randomness in a system.
And finally, we have the third law of thermodynamics, which deals with absolute zero temperature. It states that it's impossible to reach absolute zero temperature by any finite number of processes. Basically, it's like trying to get your ex to return your text after you've messed up one too many times. It's just not gonna happen. Now let's apply what we learned in a demonstration. The demonstration includes a balloon with an air dryer, and the air dryer blows on the balloon to expand it. As you can see, I am blowing into the balloon a little bit to show how much it would expand when you first blow it. Now I got a blow dryer and I turn it on and I blow the balloon. As you can see, it is expanding a little bit, and it shows first, second, and third law. If you remember, the first law of thermodynamics states that the energy cannot be created or destroyed, it can only be transferred or converted from one form to another. So in this case, the balloon and the air dryer, of the balloon and the air dryer, the electrical energy from the power source of the hair dryer is converted into thermal energy. The heat is then transferred to the air inside of the balloon, increasing its internal energy. Now, the second law, it shows that it deals with the concept of entropy, which is the measure of the disorder or randomness in a system. So in this example, as the hairdryer blows hot air into the air balloon, the air molecules inside gain kinetic energy and move more rapidly. This increased molecular motion results in a greater degree of disorder or randomness within the system. The second law states that the entropy of a closed system tends to increase over time. Now, in the third law, it states that it is impossible to reach absolute zero temperature through any finite number of processes. While the scenario with the balloon and hairdryer does not directly relate to this law, it is worth mentioning that absolute zero is the theoretical lower limit of temperature, and no further cooling can occur beyond that point. So by looking at the correlation between the balloon and the hairdryer, we can see how these laws apply. The conversion of the electrical to thermal energy and the increase of the entropy and the concept of thermal equilibrium all correlates to thermodynamics.
So there you have it.
Alright, so there you have it, the principles of thermodynamics. Explained in a way that hopefully is not too boring.
Not too cool.
Yeah.